Good morning, class.
Good morning.
Om Swastiastu.
Om Swastiastu.
Assalamualaikum warahmatullahi wabarakatuh. Shalom, nama budaya, salam harmoni.
Salam harmoni.
Okay, today we will discuss about normalization. And we all know that in class meeting we have discussing about how we transforming the entity relationship diagram into relational model. Okay, before we continue to discussing about normalization, maybe I need to list your presence. Okay, I will call your name and then maybe you need to respond. Okay, first one, Wayang Juli. Okay, and then Putu Raditya, Nadine, Utami, Ibu tuh Gede Andre, Gede Pano Arta Wijaya, Gusti Ayu Pratnya Saci Dewi, okay. Resa Fahullah, okay. Putu Aditya Udiana, and then Gusti Michael Ferdinand, from yesterday. Okay. Antonius Marcelino, sick. Dwi Permana Putra, Giovas, Miranda Febrianti, and then Arlen Sasena, Komang Sunarta. But you don't know where he Archana, Dimade Mertadwi Payana, Christian Aninata, Betul Wijaya Dewi. Oh, you don't know. Okay, thank you. I think it's all this episode. Okay, next we will continue about normalization. But before that, we need to brainstorm in first. Maybe we need to review some material in the last meeting. I need to know. Did you still remember about our last material? Okay, maybe the first one I need to know. In the process of transforming the entity relationship diagram, we have some steps. Maybe someone can help me to explain the step to transforming entity relationship diagram into relational model. Maybe someone can help me. Did you want to try?
When we want to transform ER into database relational database, we have 7 steps. The first step, we have to determine the regular entity first.
Okay, the first one, we need to identify the regular entity type or maybe the strong entity type, right?
Right.
Okay. The second one?
The second one, we have to identify the weak entity.
Okay.
And then we have to identify the one-to-one relationship and one-to-many. The fourth thing is one-to-many. Yeah, one-to-many.
And then
many-to-many.
Many-to-many.
Yeah, many-to-many and
forget the two last things that you
I forgot one thing last, but ternary
relationship, and then the last one is
maybe I want to determine the multi-value attribute.
Okay, that's correct. Yeah, we need to identify the attributes that maybe have type of multi-value attributes. Okay. I will present it. The first one, we need to identify the strong entity type or regular entity types. The second one, we need to identify the weak entity type. We need to transform transforming it into a relation. Okay, right? Into a relation. So the weak entity or the strong entity will transform into a table or maybe a relation, not relationship. That's different. Okay, please remember it. And then after we find the strong or regulative entity type and weak entity type, we need to identify each type of the relationship between two entities. Okay, if we find one-to-one cardinality or maybe one-to-one relationship, we have three type transformation. The first one, maybe we need to combine the entity into one relation or table. The second one, maybe we have to create an foreign key. And then the last one, we need to create a new relation or a new table. Okay, from the relation between two entities that have cardinality one-to-one. Okay, understand?
Yes.
Yeah, okay. After that, we have one-to-many relationship. So if we find the one-to-many relationship, we need to adding extra attributes in many cardinality that contain key attribute in one cardinality entities. Right? Okay, the last one, if we have many relationship, we need to creating the one new table or one new relationship. Okay. Okay. I think it's enough. And then how we need to review the last material, because if we want to do some normalization, it becomes from the relational model. So we need to create the good, or maybe we need to design the good ELT first before we transforming it into relational model. Because if we create the bad design, so we will result in the bad relational model. Okay. Okay. Next, we will discussing about normalization. It becomes confusing maybe, because in the first meeting of normalization, we will meet the new term maybe that we cannot learn before. Okay, the first one. Okay, we have a new term of decomposition. What is decomposition? Okay, the decomposition becomes from the table of the relation that we have in relational model. Okay, in the process of normalization, sometimes we need to decomposing the relation. We need to break them into small part. Okay. So what is decomposition? Decomposition is breaking tables into small tables to get a schema that does not contain anomalies and redundancy. Before we have to discuss about the redundancy. What is redundant? What is redundancy? Can someone give an explanation? Who remember about? Okay, please write it.
I don't know if it's like it's correct or not, but redundancy, from what I know, is there's like some little error in the data, so it causes so many problems because of that little error.
Little error in data.
Yeah.
Redundancy.
Yeah, redundancy.
Okay, maybe someone can add an extra explanation, maybe, or maybe someone have different opinion about the redundancy. No one? No one? Okay, maybe I have some example. The first one is maybe if we have an entity like a student or maybe a college, okay, maybe we need to Oh, sorry. I need to draw it first. We have an entity called student, maybe. Okay. So we will have several attributes. The first one is the key.
Yes.
What is the key for student? Identification number. Identification number. Okay. Identification number ID. And okay, we need to write the underline to showing that attribute is key attribute. And then maybe we have name, and then what else? Address. Okay, address. Okay, maybe we can just put one attribute, just one attribute. Telephone number maybe, or maybe email. I think we just write email. I think it's enough. If we don't have key attributes, so if we transforming it into relational model, it will be a relation, or maybe a table, one table. So if we create the tables, the relation with all the table name is student, and then we have 1, 2, 3, 4 column, right? Or we call it in relation. The column we call it with field, similar with column. Okay. This is we call relation. Okay, it will be more confusing because we using the new term like this. Okay, the first one we have IDN. It will be primary key. But in the ERD, it calls key attributes, right? Yeah. So it will become confusing then. Yeah. We still need to using it in relational model. Okay, I will continue to write IDN, and then we have name, address, and then email. Okay, so if we don't have the primary key, like that, so if I try to write your name, who is your name? The full name? Gebetano. Igede Tano, like that. Address? Kaliasam, okay. Kaliasam Street.
Yeah.
Where is that?
Lovina.
Oh,
yeah, Lovina. Around Lovina.
okay. Kaliasam Street. Your email, or maybe I write the dummy email, okay? Tandi at gmail.com, maybe like that.
Yeah.
So after that, I will write about 1 million students, and then in the last, I just write Tano IGD. Can be.
Yes. Yeah.
Can be. I will write like this. Maybe I say your address is in the Bulanan Presidency, maybe Bulanan, and then the email is tano at gmail. Okay. So if we don't have private key, it can be write the same person as two different data in the table. It called redundancy. Redundancy. Duplicate data. The simple I say duplicate data we found in the table. It called redundancy. And what is anomalies? What is anomalies? This is a new term of relational data model. So I'm just explaining for you that anomalies is the effect of any process that becoming maybe redundancy or maybe error to accessing that, or maybe we have some null values. It becomes from breaking the table. For example, if we have like this student, we have address. Did you know that address is composite attribute that can be composite attribute? So it can be part of address is the first one maybe street, and then village can be village. Postal code. Postal code. Okay, postal code. So if we creating table from the student entity, we can write like this: IDN and then name. Just write the simple attribute. Don't use the composite attribute in relational model. Okay, just use the simple attribute. Street and then village, postal code, and then email. Okay, the last one is email. Okay. In the composition process, we need to know the new term again. It's called functional dependency. That I will explain it next. Okay, but for example, I will try to breaking or decomposing this table into two tables. Why we need to decomposing it? Because we have one attribute that maybe it can be have functional dependency with another attributes. Because if we know the postal code, maybe just example, 80237 like that. It can determine the street and determine the village, right?
Yeah.
So we can just keep the postal code in student relation and break the street, village, and postal in the new table. The table will be, we have two tables: postal code, street, village, and the student will become only have IDN, name, and then postal code and email. So postal code can be referred to this postal code. Sorry, the arrow is swept. This is called functional dependency. There is functional dependency in relational model. Okay, that is composition. So we are going to the next slide. Okay, I don't think it need to be discussing again. We just go to the next slide. Okay, this is the database design process already. Okay, to create an ERD and database design, the first one we need to gathering user or business requirements, right? We need to find some requirement and then develop the ER model based on user or business needs. After that, we need to convert the ER model to a set of relation using transformation process, and then normalize relations to remove anomalies. That is the purpose of normalization. Okay. And then last, implement it in the database by creating a table for each normalized relationship. So the normalization form is the process that we need to create the normalization relationship. Okay. Okay. What is database normalization? Okay. Normalization is the process of restructuring a database to eliminate most ambiguities that can be contain null value, redundancy, or something like that. Yeah. Okay, the step of normalization starts from the simplest 1NF to the most stringest 5NF. So we have 6 normalization stage. But we can see number 1 to number 5 only 5 stages. But why we have 6 stages actually? Because in the middle of the state we have voice code normal form. The state is after third normal form. So the state is 1 normal form, 1NF, 2NF, third NF, B, C, and F, fourth NF, and the last is fifth NF. But you don't need to worry because we just discuss only until the 3 or the third NF. Okay, because in third NF the table is in the effective or efficient norm form. Okay, why we need to do some normalization? Because we need to optimization of table structure and then increase the speed of the query process, and then eliminates the same data entry, remove the redundancy, and then more efficient use of storage media. And then avoid anomalies like insertion anomalies, because if we do some process like insert in query, it can be affecting anomalies in another table, and then deletion anomalies, update anomalies, and improve data integrity. Yeah. Okay. Normal table. A table is said to be good or efficient or normal if it meets the following 3 criteria. Okay, the first one is if there is composition of the table, then the composition must be guaranteed to be safe or lossless join decomposition. What is the meaning of lossless join decomposition? We can use the last table that we create. Okay. If we want to break the student table, we need to find the right functional dependency of each attribute. Okay, we need to find the correct functional dependency. But if we choose the wrong attribute, maybe we cannot relate the table. We cannot make the relation between the table. Okay, if we choose, for example, if we choose the street, maybe we don't choose postal code, so we cannot make a relation between the student and maybe we can see that inference, right? So we need to find the correct functional dependency. Okay, like that. That is the meaning of lossless join decomposition. Decomposition means break down the table, and then lossless join meaning of we need to create the correct functional dependencies. Yeah. Okay, and then maintaining functional dependency when data change. Okay, dependency preservation. Data violate voice code normal form. If we don't find the third, if we don't have to, at least the table does not violate the third stage. So if we reach the third normalization form, we just need to do voice code normal form. Okay, we just need reach the third normal form first. If we doesn't meet the third normal form, so we need to do voice code normal form. Okay, so now we will discuss about the functional dependency. I think you going to sleep yeah? Because I think many of the new term in this relational model. Okay, but we still need to discuss it first because we jump to the normalization process. We need to know the term first. Okay. Yeah. Okay. The dependency is a concept underlying normalization. And then dependency describes relationship between attributes, or more specifically, explain the value of one attribute that determine the value of another tables. Another attributes. There are several types of dependency. The first one is functional dependency. Okay, the second one is full functional dependency. Okay, and then transitive dependency. That is different. That was different things. Okay, and the last is total dependency. We have 4 types of functional dependency. Okay, 4 types. Yes. That will be used in the second normal form, third normal form. First normal form doesn't need to identify the functional dependency. The first normal form is the simplest process, the simplest stage. Okay. So we just discussing about the functional dependency. Okay, functional dependency describe the relationship of attributes in a relation. I typo. An attribute is said to be functional dependent on another if it uses the value of that attribute to determine the value of another attribute. We can change the price using value. Okay. The symbol used is we can use arrow, right arrow, okay, right arrow. We can read that by functionally determined. This is a notation. Okay, we have pembeli relation. We mix bahasa. Okay, we mix bahasa and English. We try to find the functional dependency. In pembeli relation, we have two fields. First one is nama pembeli. Second one is nama pembeli. I hope you understand. Okay.
Yes, okay.
If we have nama pembeli, and then we can determine the nama pembeli. For example, if we have nama pembeli P01, it will be determined Imam X. It will be the same with the identification number. Here, the identification number maybe 00001 determine Hano. Okay, we can write that like this. Nomor pembeli. Okay, pembeli determine nama pembeli. How if we have more than two attributes? Okay. So we need to add in extra attribute, maybe in the determinant. Nama pembeli, maybe we can have address, and so on. Using what is the name of the bracket?
Curly bracket.
Curly bracket. Yes. I don't know what they call in English. Sorry. Yeah, like that. Okay. The part of the left of the arrow is called determinant. Sorry, the left. This is the determinant. And then the right side is called the dependent. Okay, it's called it dependent. Okay, I think it's enough. So we go to the next example. Okay, it's in bahasa. We have courses or maybe mata kuliah, and then we have identification number or NRP, and then we have name and grades. Right. So we need to do some analysis in based on the relation. We need to find which attribute affecting another attribute. Okay. If we pick, or maybe if we choose the mata kuliah, I think that's not affecting another attributes because we have in the row one, it called row in relational data model as tuples, or records. We say that tuple or record. Okay. We check it first. If the mata kuliah is aplikasi web, in the NRP is 7405040100, and then we have another NRP 7407S50400101. Different NRP using mata kuliah aplikasi web. So mata kuliah cannot be used for determinant. So we need to find another attributes. Okay, maybe we choose the NRP. If we have NRP 7405040100, the name will be Deni Astika Putri. So you need to check to make it to ensuring first any name using NRP same like this. Yeah. We need to check it first. We check. Oh, it has same NRP and same name, right? and then we don't see any same NRP have another name. Okay, so we can choose NRP to be a determinant. Okay. And NRP will be determine the name. Okay. And then if we have NRP 7405040100, can we have only one mata kuliah, or maybe can be more than one? If can be more than one, that cannot be determinant to mata kuliah. Cannot be. So we need to break the table like this. NRP will be determined nama, but we need to find the grades and mata kuliah. Okay. How we know that any Astika Publik will have grade A in aplikasi web? We cannot just using the NRP, because one NRP can have more than one mata kuliah. Yes. Right? So we need to combine the NRP with another attributes. Okay, from the example, we can combine the mata kuliah with NRP to determine the grades of the line. Okay, so we can combine it into one table. So we will bring two tables from this relation. That was the process of the composition. Okay, we need to find the functional dependency. This is the functional dependency. How to write like this based on the example. Okay, I hope you understand. Maybe if you have some confusing or maybe still don't understand about my explanation, maybe you can interrupt me, raise your hand, and ask what is the next question. And then if you need the explanation in bahasa, I will give it to you. Can we continue, or maybe
Yes.
someone need to discussing it first? Continue. Enough? Okay, enough. So we're going to the next. What is functional dependency? If we have one attribute, we call that Y has full functional dependency on attribute X. If Y has a functional dependency on X, and Y has no dependency of any part of X. Okay. The notation will be same with the previous. For example, there is a pelanggan relation. I can show you the table. Maybe this is just only explanation. Okay. In relation pelanggan, we have 4 fields or maybe 4 columns. The first one is kode pelanggan, and then nama, and then kota and number fax. And in this relation, we can identify that kode pelanggan and kota will determine the number fax. But number fax only affecting by kode pelanggan. We doesn't need kota. Okay, this called number fax full functional dependency with kode pelanggan. Okay, we can ignore the kota. Without kota, we can determine the number fax. Simple like that. Okay. Okay. maybe
I don't get the difference like the previous dependency.
the previous. Okay, we have.
I don't know what's the difference. So in my in what I get. Do the functional dependency comes from the unique entities or field that has the unique, I mean like unique attributes, unique field that give a unique data to, like for example, our name, identification number give us the name of the student. And what's the difference with the full functional dependency?
Okay, full functional dependency. I think it's same with your opinion like that. Fully functional dependencies says that the number of facts only affected by kode pelanggan. But the previous example, maybe we can go to the previous slide. Okay, previous slide again. If we compare, maybe difference. So if we need to know the data about nilai, we cannot just only using NRP, right? But the nilai will be needed one combination of mata kuliah and NRP to determine that. So the full functional dependency of nilai is mata kuliah and NRP. Full functional dependency, but different with last example like this. If we using kode pelanggan and kota to determine number of facts, maybe we can say that wasting the kota. Okay, we doesn't need to using kota to explain that. So the number of facts only full functional dependency with kode pelanggan. Okay, because if we have combination like this, maybe we can put another attributes in the next nilai. Maybe some attribute like after nilai, maybe we can put keterangan maybe, or the description maybe. Like that. Okay, this is only simple example. Yeah.
Okay.
How about that?
Yeah.
Maybe. Did you understand, or maybe you just get or maybe more confused?
So can I say that full functional dependency is like a field table that has that can determine the many things. For example, like let's say our name, identification number can determine our name, our majority, our.
Okay, that is functional dependency. Fully functional dependency will be the relation between determinant and dependent. Yeah. The dependent fully functional dependency with number pembeli. And maybe if number pembeli affecting number pembeli and address, it called full functional dependency too. Same thing. Okay. But if getting confused, maybe I will tell you in bahasa. Maybe more difficult to explain it in English. In bahasa, kita ingin mencari keterkaitan antara determinan dan dependennya. Jadi kalau dia full, mereka keduanya saling berkaitan, nggak bisa dipisahkan. Tapi kalau fungsional dependency bisa jadi nomor pembeli mempengaruhi banyak, ya, tapi salah satu di antaranya itu tidak terpengaruh oleh nomor pembeli, bisa dikeluarkan. Just like that. Okay. Get it? Okay.
Thank you.
Maybe another question? Yeah.
So basically, all of the flow we can make the functional dependency from all of the flow.
Yeah.
So it's basically it's back to the case.
Yeah.
Like the case is the case need to make the functional dependency from one column to another. We can make that. So basically, there's no rules like there's no rules for it must be primary key or something like that. It must be foreign key for make the functional dependency.
Yeah. There is no, but mostly the functional dependency is the key attribute. Not only primary key, but key attribute. Maybe key and candidate can be like post output and post output. There is candidate key in one attribute, one relation. So the role is the maybe we can say that functional dependency maybe comes from key attributes or maybe key candidate like that.
So maybe in the practical case, where do we need to put or where do we need to describe what is the functional dependency? What are the functional dependencies?
Practically, maybe we don't need to describe, but we need to find the functional dependency to create a new table in the second normal form. Because the second normal form, we need to identify that relation have more than one functional dependency. So we need to break down into two tables. So we have the normal relation. Like that. This is the constraint of second normal form and third normal form. So we need to know what is functional dependency, and then the next is what is transitive dependencies like that. Maybe someone have another question again, or maybe it's enough. So we can go to the next discussion. Okay, this is okay. The third one is transitive dependency. Transitive dependency ini bahasa ketergantungan transitif. Okay. Maybe if attribute Z has transitive dependency on X, if Y dependent on X and Z dependent on Y. Maybe bahasa keberlanjutan gitu ya. Misalkan X bergantung dengan Y, Y bergantung dengan Z. Yeah, like that. So maybe I have give the example to you like this. IDN maybe affecting determine the post output, determine the street maybe or the village maybe like that. So we can create a notation like this. IDN will be determine the post output, and that post output will be determine the village. Or maybe we have more than one attribute, we can using the curly bracket. Village and maybe street. We doesn't need to put the post output again in the dependent. So maybe we can say that IDN will be determine the village and street. But in the third normal form, we need to break our decomposition the table to IDN post output and then post output and this. So we will have two relations. Like that. Okay? Okay, for the example, we have relation in shipping, maybe shipping, and then we have field like nomor pembeli, kode kota, nomor barang, and jumlah. So we need to identify the functional dependency first. Okay, first one, if we choose nomor pembeli as determinant, will be determined which attribute? Which attribute will be determined by number pembeli? Kode kota? Like the answer. Okay.
Yeah.
Because we can see that if the number pembeli is P0 plus 01, so the kode kota will be 1. If the number pembeli is P02, the kode kota will be 3. And then the last, if the number pembeli is P03, the kode kota will be 2. But we need to know how the relation between number pembeli and number bar. It has relation or no? You can see it. If we have P01, the number bar will be B01 or B02 or B03. There is no functional dependency between number pembeli and number bar. Okay. What about the kota? What about the kota?
Oh yes. Kota. Kode kota and kota.
Kode kota and kota. I need to clear the word first. Okay. Number pembeli will be determined kode kota. How about the kota? Can we just only say that number pembeli will determine kota? Can we?
No. Yes.
Why?
Yes.
Yes. Why yes?
Because
Why? Yeah.
Because number pembeli basically determine the kode kota, and then the kode kota itself, we see like the kode kota is one. The kota name will be Jakarta, and if the kode kota is 3, and it will be Bandung, and then if the kode kota is 2, it will be Surabaya. So that's just like one possibility to each of the kode kota.
Okay. That's right. So we just need to write it first, the process, the step-by-step process. The first one is number pembeli will be affecting kode kota, and then kota like this. Okay. But after that, we need to identify, can the kota just only determined by kode kota?
Yes.
It can, so we need to write it down. Number pembeli will affecting kode kota, and kode kota will affecting kota. Yeah, or we write just like this. Okay. It called transitive dependency. Transitive dependency. Okay, just like that. Okay. This is needed in third normal form. Oke, jadi kita akan membuat ini menjadi sebuah tabel baru lagi. Maybe we need to create a new table. Nomor pembeli with kode kota, and then kode kota will be with grid kota. And this is in third normal form. So we need to decomposition tables or decomposing the relation. Okay, any question? No. Okay, total dependency. We just need this. Can we skip this one? because in the third normal form it doesn't need this. Yeah, we just skip this. Okay, we are now going to a normalization process. The first normalization, maybe after that, maybe we can do some discussion. After that, we will close the class. This is the step of normalization. First normal form, second normal form, third normal form, boys code normal form. Okay, and then fourth normal form, and the last fifth normal form. Only six steps. But we just only discuss until third normal form. Okay, it's only the third normal form because if we do until the fifth normal form, it can make our query process more complicated. So the practitioner will be avoiding normalization until fifth normal form. Okay, the first normal form is fulfilled if a table does not have multi-value. So the constraint is multi-value. The first one is multi-value. After that, composite attributes or combination thereof in the same data domain. So they always pair of problems in database, multi-value and composite. Okay, we need to upgrade that. Data is from one record after another, one record one by one. And unfilled values are atomic values. The values in the field must be atomic. Okay, that cannot be like hobby. Maybe I created hobbies. Someone maybe have more than one hobbies.
Yeah.
Hobbies, yeah. Yes. Maybe sleeping. Sleeping. After that, maybe like jogging. No. Jogging, yeah, jogging. What's gymming? I only know gymming. Gymming, I don't know gymming. Gymming, I don't know gymming. Sleeping, jogging, maybe. Flying. Playing what? What playing for? Playing games. Oh, games like game. Yeah, games. And many other hobbies. Yeah. What hobbies? Sleeping. Only sleeping?
Yes, and I love.
If you don't love dating,
I don't have.
what? Reza, do you want to Reza no hobbies? Oh yeah. Oh, okay, that's no problem. Yeah? Between jogging we cannot write like this in database. We need to avoid this. So we have any rule for this kind of attributes. Okay. The last one is no repeating of double value attribute sets. Same thing, I think. Okay. We can see the example. If we have tables like this, basically not came from transformation, not came from the process of transformation from ERD into relational model. It commonly comes from if we create database using any real problem. For the example, if we have what we call I forget about English. Nota. What do we call nota? Invoice. Okay, maybe we can create a database basically from the invoice. So we doesn't need, I think I doesn't need to create the ERD first because I'm professional. Yeah, can be the practitioner really doing ERD before create the database. Okay, like that. So maybe from the invoice we create the table. It can be written like this. If we have one invoice, the field maybe become complicated because this is we have font name like that, address, right?
Yeah.
Address, and then phone number. This is invoice ID, like that, right? And then in the table we have the part, maybe some part of to create a building.
Yeah.
What is cement in English? I don't know. Cement, like this, cement. Cement. Basic. Okay, right. So we can put it down, write down in the header of table, maybe ID part, items, and then maybe we have quantity, yeah, price, and so on. So we can write it freely. Items, maybe cement, basic, and cement 3 roda maybe, like that. So it becomes complicated if we transforming it directly into relational model. Just like that. Maybe. Yeah. How about that? A relationship is in first normal form if the relationship does not contain multiple attributes. But how we transforming it if we find multiple attributes?
You can do it twice, or you can. You cannot input it twice.
Input it twice. Did you mean Anian baru right to?
Yeah,
Right to.
but different classes.
Different bahasa. Right, that's the process. Like that. We need to get analysis. Okay, right, like that. So we can see the solution. Remove multiple attributes and then set each column to contain one value, only one value. If they have more than one, spirit them into another data or another record. If the content of a column for a row contain and value, then split the row into n rows. Same like my explanation or Radin opinion.
Yes.
Same. Okay, how about that? Understand?
Yes. It's easier to understand.
Okay. Okay, we have tables like this. Why it becomes bad relation?
I think there is a null or some record data that not built in the.
Okay, same data contain null value.
Yeah.
Same that some data contain null value. This and this and this.
Yeah. It's bad.
How we handle that? How we can handle that? It called multi-value, right? bad, bad, uh, bad table structure. How we can handle it? Okay, I think maybe someone another, someone else. Reza, maybe did you want to try? Do you want to try? Do you understand? Little. Nadine, maybe? No. Arlen? Arlen? What is the meaning? Okay, if you cannot say in English, maybe you can say using you can use bahasa for the explanation. Reza, maybe you got behind Chris. The guy behind Chris. Behind.
Please here then. Same.
Okay, you can freely use bahasa. Korti apa? Korprodi. Korma Ipong ya. I forget your name. I'm sorry. Do we using X or K? Okay. You can really using bahasa if you want to explain how to handle this condition. Using bahasa, can using bahasa. Did you don't understand? Yes. Okay. Another one maybe Utami Orsachi. Utami Orsachi. Could you explain?
In bahasa.
Okay, that's not problem.
Mungkin kalau menurut saya itemnya itu kan ada 4, jadi kenapa nggak dijadiin satu aja? Jadi cuma ada 4 kolom gitu. Kalau nomor pesan, tanggal pesan, item sama total.
Yeah.
Itu kan
What is the difference?
Kalau saya kira tadi item-itemnya itu beda semua dia P1, P2, jadi nggak ada yang double. Terus saya baru melihat ternyata ada yang double dia P1, P2 nya.
So,
I think I'm wrong.
she cancel. She cancel yes. Okay, we could channel again. Another one. Someone else. Judy. Okay, Judy, can you try?
Maybe we need to
set null for the blank item. We just write null like that. Yeah. Okay. Maybe okay, Chris.
Maybe we need to input the data first.
Using
I don't know.
maybe same thing like Julie asked before. You can put no value in here like that maybe. Yeah. How if another invoice have more than 4 items?
Okay, what about just deleting the rows that are next to
So we need to write like that one. We spell them or maybe what do you want to spell the data? Create new record or maybe no? How did you want to do?
I want to just delete the.
Oh, delete
Yeah.
the notary.
No, the rows.
The rows. That
That
content number you. If we delete the rows,
It's
so we don't have the data.
Yeah.
We don't have the data.
Just delete the record.
We missing the income if we delete the data. Maybe what is funny opinion? Maybe you can just try to say that. Apa yang ingin tadi disampaikan? Coba sampaikan aja dulu.
Itu keempat item itu dijadiin satu gitu. Jadi cuma ada satu kolom.
Item bentuknya kayak gimana?
Iya.
Kan tahu ya? Oh, kan. Maybe Utami answer is not wrong, but you need to add some condition. We need to create it with we need to grouping in one columns or one field, like item like that, and then we write like this. After that, what we need to do? Just like the previous explanation. Okay, we need to grouping only use item. We doesn't need to write item 1, item 2, item 3, item 4. Doesn't need. We just need to preparing only item columns, and then we grouping another in one column. P1, P2, P3, and P3, P4. After that, we spread them into a new column.
That's what I have.
Level will be
Oh,
okay. So we can write the ID more than one times.
Can I ask how can we write the total to 45,000? Can we just write the total like as what the price of the item?
Okay.
Not the total. If we see it here, we can say it's a little bit complicated because the record data is there are a lot of record data with the same value or same total.
It's a total. So the total will be from total.
I think.
Yeah.
If we just put the price on every item in the total price, or which is the field as total item, and then we can set the item is on how can we determine the total price if we write it down like this.
Okay, the next question is where we can find information about the price of each item.
Number percent.
Okay, we going back to previous slide. Where we can find the price of each item. If we need to write it with different total, where we find information? We don't have the information about that. So you doesn't need to worry because this is only the first step of normalization. After that, we need to separate decomposing the table using second normal form by finding the functional dependency first. Okay, until the third normal form. So if we reach the third normal form, I think it can clearly solve it.
So if we are in the first normal form, we just keep it like that.
Yeah, just keep like this, and then we need to continue to next stage. Okay. I think that's all my material. Okay, maybe any question?
So much question in my head.
Okay, that's no problem. Because after maybe next week we need to discuss about this internal form that's more complicated. More complicated because we need to find the correct functional dependency. If we want to decide the attribute that contain functional dependency, it will becoming the wrong result. Okay. Thing like that. So before I close this meeting, maybe someone have a question. Okay.
Do the anomalies will decrease if we do more normalization?
Okay. The answer is based on your normalization process. If you do wrong process, it becomes anomalous. But if we do normalization until 5 normal form, I think in every step we do the correct process, maybe resulting the 0 anomalies. Like that. But the process to query data will be more complicated. Maybe need more time. Why? Because if we split the tables, in query we need to do join operation. That increasing the time. So the practitioner will only using until thread normal form. The rest is they do not do the rest of normalization because they think until thread normal form it becomes normal. Good relational model.
You say that if we reach the 5 normal form, there will be 0 anomalies. So if we already reach the third normal form, it means that it's basically possible to have anomalies.
Based on practice, rarely find anomalies after we reach third normal form. So the criteria, we're going back to last criteria. We have 3 criteria. Where is that? Okay. If we doesn't need, we need to reach voice code normal form. If the third criterion cannot be met. Jadi kalau misalkan kita nggak bisa sampai third normal form, kita harus mencapai voice code normal form to find the good relational model. Okay, but we need to know first how the process in second normal form and the third normal form. Next week, maybe many questions.
Yeah.
Many questions. But if we do some exercise based on example, maybe it becomes clear. Okay. But if we don't have to try, I think just like the RD. Yeah. Any confusing or maybe kind of that's not correct for the result. Okay, like that. Any question again? Okay, one.
Do we do the normalization manually, or is there like any computer tools that we can use to normalize?
There is no computer tools to do normalization. Only using manual intuition.
Yes.
Yeah. But based on the step by step.
That's the way I.
So your final project. So your final project, okay. Before you have done to create the RD diagram design, okay. The first step is pass. And then the second one, we need to transforming it into relational model. Okay, step 2 pass. I don't know. Have you tried to transforming your ERD before?
Not yet.
Not yet. Okay, maybe from now you can try to transforming it into relational model. So if you have any problem, you can ask me in the next meeting. So you can freely ask me not only about this material, but you can do some discussion about your project. And maybe we have the last exam in 25. 25. Or maybe we take it at 2 July. 2 July. Because the last schedule to doing the last exam is 12 July. 12 July.
Oh.
You can pick between 25 or 2 July. 25 June or maybe 2 July. 2 July. Because I think now is the 14th meeting, right? 14th meeting. But you don't validate it. Okay. Maybe you can help me to validate it. Until 14th meeting, so we only have 2 rest meeting. Okay, only have 2 meeting. So now it's 11, right? Okay, next week is 18, 25. So you can pick 2 July or 9 July. It's on you. It's up to you. But we can decide it now.
Do we need to present our?
Yeah,
of course. That's the violation.
Okay, maybe I can give you just another choice. Maybe you can, if you're ready to present your final project, maybe you can just
Go ahead.
informing. Yes, just go in. Okay. Maybe if you want it, 25, maybe you can do it 25. Yeah, because the last material will be explained in the next week until November. After that, the material is.
So we are not present our project in front of our classmates.
In front of class.
Oh.
Still in the schedule. Still on schedule. But in 25 interesting. Okay, 25 and then 2 July and 9 July on schedule. Or maybe, but we need to find another class if you want to change the schedule.
I think it's better if we just determine right now when we are doing the presentation.
Okay.
So we all of us can prepare our presentation well.
Okay. That's no problem. It's up to you.
Yo,
2 July. 2 July, okay? One.
present to Julie.
2 July. Again, present 2 July. On 2 July 2024.
Whoa.
It's okay if the last exam will be taken on 2 July.
Yeah.
Yeah, it's okay, or maybe someone have to.
It's
Just to
okay.
be clear, the exam will be presenting our project.
Yeah. It's only presenting your project based on
Yes, more fast, more good.
More possible. Good.
or more good. Can be like that. It's okay if the last exam will be taken on 2 July 2024.
Yes.
Okay, we will decide. take this seat. Okay. So, any question before I close this meeting?
No, for now.
Enough?
Yes.
If enough, I will say thank you for your attention, and then maybe the next week we will discuss again about the normalization, the second normal form, and the third normal form stage. Okay, after that, I hope you understand about how to predict the database based on theory. Okay, I think it's enough. Good morning. Om Santi Om. Wassalamualaikum warahmatullahi wabarakatuh. Shalom, namo buddhaya, dan salam.